The video shows the calculation of the fillet weld of a sheet metal joint. The notch stresses are determined using the R1-Concept. The radii at the weld root and weld transitions are 1 mm. The calculation model is shown as it deforms under a static load. A new project is created in winLIFE, for example 15. A welded component with notch stresses is calculated. The cyclic load is to act in the form of a load collective. We will use the FE results of the NASTRAN calculation directly. These are the DAT file and the OP2 file. We will now generate a SN curve for the weld seam. As the base material, we will select steel S235JR from the FKM database in winLIFE. The material is available in several versions for the various FKM editions, as can be seen in the table. We will select the material from the current 7th edition, i.e. from 2020. The window on the right-hand side is now expanded and the following values are specified. The component class of 200 for this seam radius of 1 mm. The sheet thickness. And the type of welded joint. The SN curve is generated. The load is now entered. For this purpose, a load collective is generated. This is a pulsating load with a maximum value of 5,000 newtons. 100,000 cycles are applied. The collective is saved. The radii at the seam were modeled uniformly at 1 mm. This allows an automatic search function to find all nodes that lie on the curves of these radii. Because the radii in the FE model are never exactly 1 mm, a tolerance range for the radius is specified from minimum to maximum. In the next step, the FE data is imported. This consists of the geometry file with its mesh information and the OP2 result file. The FE calculation with NASTRAN was performed with 1,000 newtons. And the stresses in the OP2 file refer to these 1,000 newtons. The strain energy hypothesis is selected as the comparative stress hypothesis, which also fits the component class of 200. The weld seam is now selected, or more precisely, the 3 notches of the seam. The viewer opens and displays the model with stress results. The radius 1 curvatures were found automatically and the corresponding nodes were placed in 3 node sets. The check marks in front of the node sets are already there, and the nodes of these 3 node sets are used in the service life calculation. To do this, click on OK. Note, the curvature search can currently only be used for volume elements. We select elementary form in order to obtain damage in any case, even if the stresses are below the fatigue strength. The classification of stresses is specified in the calculation menu under parameters. We leave the 100 classes as set. We select amplitude transformation. The calculation results in the damage sum. The report shown and the SN curve will not be discussed in detail here, as other winLIFE examples do so in detail. More important now is the visual representation of the damage. To do this, the viewer is opened. As expected, the location of the highest damage is at the root of the seam. This was already foreseeable based on the comparative stress distribution for this one load case. The low damage value of 0.05, which is well below 1, indicates that the load collective can be endured multiple times. The report provides more information on this. Only the nodes on the curves were evaluated in this calculation. All other nodes therefore have no damage here, i.e. a value of 0. In addition to the damage sum, other damage values can also be called up, as shown here.